Welcome back, focused learners. Today, we are finally tearing the lid off the black box of large language models. You know the drill, right? You type a question, hit send, and literally within seconds, you get this incredibly detailed, intelligent-sounding response. Honestly, it feels like magic. But today, we are replacing that magic with mechanics. Because really, understanding exactly how this system works under the hood, that is the ultimate secret to actually mastering it.
So what's actually happening in those few seconds between hitting send and getting your answer? Look, it's super tempting to imagine this tiny, super smart robot sitting inside your computer, reading your words, pondering them, and writing back to you. But here's the thing. AI doesn't read human language, and it certainly doesn't think like a human. Instead, when you hit that button, you are triggering a completely mind-blowing mechanical chain reaction. Just to give you an idea of the sheer scale we're talking about here, a complex AI model uses around 175 billion parameters. Billion, with a B. In a single second, it's performing billions of mathematical operations across this massive cluster of GPUs, all just to decide what to say back to you. It's basically a symphony of pure math happening at absolute lightning speed. So here's our roadmap for today's explainer. First, we've got the magic box revealed. Next, turning words into numbers. Then, inside the transformer brain. After that, the prediction engine. And finally, mastering the art of prompt craft. Okay, let's dive right into section 1, the magic box revealed. We really need to stop thinking of AI as a conversational partner and start treating it like what it is, a highly efficient multi-stage assembly line. Every single prompt you type travels through 4 distinct stages on this line. First up, it gets tokenized. Second, it gets embedded into a mathematical space. Third, it gets transformed through layers of attention. And fourth, the model predicts the output. Seriously, if you understand these 4 steps, you understand AI.
So let's break down that first step in section 2, turning words into numbers. The absolutely crucial concept to grasp here is that AI cannot actually understand human letters. I mean, this is exactly why AI famously struggles with the strawberry problem, where it can't accurately count the letters in a word. It's because it literally cannot see the letters. Instead, the very moment you hit send, an internal translator grabs your sentence and chops it up into tiny fragments called tokens. Imagine taking a sentence and just breaking it apart like puzzle pieces. The AI uses a fixed dictionary of about 50,000 of these tokens, where one token equals roughly 3/4 of a word. And this right here is exactly why using simpler, clearer words in your prompts creates cleaner tokens. If you use overly complex or vague sentences, you're basically handing the AI jagged, messy puzzle pieces to work with. Now, once your text is chopped into token IDs, we hit stage 2, which is embedding. The AI takes those tokens and turns them into a massive, multi-dimensional geometric array. We're talking sometimes using over 4,000 numbers for a single concept. It's wild. This math essentially maps your prompt into this massive digital galaxy. And in this multi-dimensional space, related words form these recognizable clusters. So words like happy and joyful would sit super close together. At this point, it's no longer English. It is pure spatial mathematics. Which brings us to section 3, inside the transformer brain. Okay, so now that your prompt has been translated into a string of numbers floating around in that geometric galaxy, it is time to send it into the heavy machinery. This is where the actual processing power of the AI comes in. Those vectors flow through stacks of identical layers, often about 32 of them, using something called multi-head self-attention. Essentially, the model looks at the numbers and calculates the attention weights. It's figuring out exactly how much it should focus on every other token. This is literally how the AI learns to associate grammar and meaning. It understands that, hey, in this specific sentence, the token for cat needs to pay heavy attention to the token for Matt. And that flows right into section 4, the prediction engine. Now, this is where we really confront that whole illusion of mind. You see, AI doesn't inherently know what it wants to say. It doesn't formulate some grand thesis and then just type it out for you. Nope. Instead, it looks at all the math we just generated, and it calculates the probabilities for all 50,000 potential next words. Then it essentially rolls weighted dice to pick the next word. And that roll of the dice, that's what injects that natural creative variety we always see in AI responses. It outputs that single word, attaches it right to the end of your original prompt, and then runs the entire lightning-fast math loop all over again. It's basically just a super-powered autocomplete building its thoughts sequentially, just one single token at a time. So, how do we use this? Let's move to section 5, mastering the art of prompt craft.
Because AI generates its responses word by word, sequentially, rather than from some sort of master plan, you really have to structure your prompts intentionally. Just think about a super vague prompt like, help me write a professional email. That gives the AI very little mathematical context. So what happens? The AI just starts guessing. And because it generates word by word, if it starts down the wrong path, it will confidently just keep going the wrong way. But contrast that with a really context-heavy prompt. You define the role, the audience, the exact format, and the constraints right up front. By front-loading all that context, you actually constrain those mathematical probabilities, forcing the AI to give you highly specific, mathematically superior predictions.
But what if you actually need the AI to do some complex logic or math? Well, for that, we use a technique called chain of thought prompting. Since we know the AI predicts just one token at a time based on the previous tokens, we can actually force the AI to show its work. Instead of just letting it jump straight to a final conclusion, which, let's be honest, often leads to hallucinations, we prompt it to break the problem down into sequential steps. It really mimics human problem solving. By forcing it to generate those intermediate reasoning tokens first, the final answer becomes incredibly accurate. And the best part, you can trigger this advanced analytical pathway instantly, literally just by adding the magic phrase, let's think step by step, to the very end of your prompt. You trigger what's called zero-shot chain of thought. The AI doesn't even need prior examples. Just typing that phrase activates associations in its training data that force it to slow down, create a solid logical structure, and predict its output methodically. It's a total game changer. This whole concept actually brilliantly illustrates our ultimate cheat sheet for prompt craft. You've got to match the technique to the exact task. Use zero shot for fast, simple facts. Use few shot, which is where you provide a couple of examples, when you really need strict formatting or a specific brand voice. Use chain of thought for complex math or logic problems, and use meta prompting when you want the AI to analyze and optimize its own systems. Seriously, you might want to take a screenshot of this one. It'll save you hours of frustration down the road. So we've traveled all the way from human words to chopped up tokens to multi-dimensional vectors, straight through the transformer brain and out through the probabilistic prediction engine. AI is definitely not magic. It is an incredibly powerful, highly structured mathematical tool. So I want to leave you with this question. Are you going to keep typing vague requests and remain completely at the mercy of the magic box? Or will you apply the science of prompt craft to finally become its master? The choice is yours. Keep learning, keep experimenting, and I'll catch you in the next explainer.